asked to put my notes up for people to see. So this is lesson 1, Introduction to Motion for Year 12 Physics. So physics is the study of measurable quantities, and these quantities are called physical quantities. Now, all these physical quantities fall under two main categories. One of them is called scalar, and the other are vectors. Now, scalars have only got size, while vectors have got both size, which is also called magnitude, as well as direction. Now, the way a vector is represented is by drawing an arrow. Now, there's a difference between distance and displacement. Distance is the length of the path that you take to travel. That is the green line that you see here. Whereas displacement is the shortest distance from start to finish, which is a straight line, and it has direction. The difference between speed and velocity is speed in a particular direction, but both have the same formula. So average speed is total distance divided by total time, whereas average velocity is total displacement divided by time. So the only time you can use V equals d over t is to calculate average speed or average velocity, constant speed or constant velocity. The meaning of constant velocity is neither the direction nor the speed changes. In other words, constant velocity is constant speed in a straight line. There's also something called instantaneous speed. So that's a speed at a particular moment in time. And one way to do this is to find the gradient of a distance time graph when the speed is changing, or if the speed is constant. And if the speed is changing, you need to draw a tangent to the curve on the dt graph. And in year 12, we'll also learn formulae to calculate this instantaneous speed. But just before we go there, I'm just moving on to a review of what we did in year 11. So these are the various shapes for distance time graphs, which shows if something is stopped moving at a constant speed or constant velocity, if something's accelerating or decelerating. And I put everything together here on a speed time or velocity time graph, and A is accelerating forwards, B is constant speed forwards, C is decelerating but still going forwards. Now all this is above the x-axis. If it's below the x-axis, then it's backwards, so it's accelerating backwards or decelerating backwards.